Hello everyone, in this video we are going to discuss regarding peritectic system. So we have already studied eutectic system. So I have given the example in eutectic, right? Similarly, what are the example in peritectic system? Leucite silica, leucite. Yes, unlike eutectic system, in eutectic system, what are the example? Eutectic, just for your recall, eutectic system is like this, right? There is some composition and fixed composition and temperature, as I have told. There are two end members, A and B. For example, we are taking diapside and anorthite. Diapside and anorthite. So diapside will be at one end, anorthite will be at one end. So unlike eutectic system, what happens in peritectic, there is one middle compound also. There are two end members. Okay, there are two end members like leucite and silica. We will take two components. Okay, leucite means that is potassium oxide, right? What is leucite? Which group mineral it is? It is feldspathoid. It is a feldspathoid, right? And here silica means SiO2, that means quartz. We are taking pure quartz, right? So the end members are feldspathoid and quartz, but we will see there will be an intermediate compound in between this leucite and silica. What happens? We often people say that, yes, I was just comparing, that's why I have given this example of eutectic, right? I was just comparing between peritectic and eutectic. In eutectic there are two end members, diapside and anorthite. There is no intermediate compound or intermediate mineral. But in peritectic we are going to find an intermediate mineral. That is the difference, and another difference I will discuss with time. So what I was telling, yes, often people say that undersaturated saturated and oversaturated. In igneous rocks, we are defining this undersaturated, saturated, oversaturated silica on the basis of silica. That means minerals which are undersaturated with SiO2 percentage, which are having lesser SiO2 percentage. Oversaturated means they are having higher SiO2 percentage, pure SiO2 percentage, that means, and saturated means intermediate between them. Okay, so what happens, often people say that this undersaturated and oversaturated, they cannot coexist together. Undersaturated and oversaturated, they cannot coexist together. For example, as I have told you here, leucite, as I have told, this is potassium oxide, right? And that is a feldspathoid. Okay, that is a feldspathoid. This is potassium oxide, means potassium silicate. Okay, potassium aluminum silicate. So it is a silicate mineral, but that is undersaturated feldspathoid, and silica means quartz. Quartz means it is oversaturated. It is pure SiO2, so that is oversaturated. Another example of this peritectic system is olivine fosterite silica. Fosterite silica or fosterite quartz, you can say. Fosterite quartz. Fosterite is which mineral? It is olivine. Fosterite is olivine. What is, and quartz is your pure quartz, or that is a mineral of quartz group also, pure quartz, pure SiO2. So that is oversaturated and olivine is undersaturated. We we also know that olefin cannot coexist with quartz. Olefin cannot coexist with quartz. That means in a rock, if we are finding olefin, we cannot see free quartz there. Why? Because olefin is forming at higher temperature. Quartz is of lower temperature. So olefin and quartz, they cannot coexist. This is the thing what is in our mind before. But now we will see this peritectic system. Now we will see the this temperature composition diagram or the phase diagram of this system, fosterite and quartz, similarly leucite and silica. Okay, so I will give you the example. I will describe the peritectic system here. Then you will get to know why this olivine or this fosterite it is not coexisting with quartz, why this leucite that is not coexisting with silica, or we can say why these undersaturated minerals, that means leucite or fosterite, these are undersaturated, they cannot coexist with oversaturated mineral like quartz. Okay, if there is we can find coexistence of undersaturated mineral and saturated mineral, similarly saturated mineral and oversaturated mineral, but we cannot find undersaturated and oversaturated, right? So this is the thing that we know before. Now I am going to describe this peritectic system, from which you will get clear why this phenomenon is not occurring, why these undersaturated minerals or this leucite and fosterite, olivine and feldspatite, they are not occurring along with oversaturated quartz, right? As I have told, there will be one intermediate compound. If we are considering this leucite silica system or leucite quartz system or fosterite quartz system, then there will be an intermediate compound. In leucite silica there will be an intermediate, in fosterite and silica there will be an intermediate. We also know that feldspatite, they cannot occur with quartz. If feldspatite, they will react with quartz, what they will form? If feldspatite, if they react with quartz, what they will form? They will form feldspar. So in this case, feldspatite is undersaturated, quartz is oversaturated, feldspar is saturated. We can find coexistence between feldspatite and feldspar. That means in an igneous rock we can find feldspatite and feldspar both, or we can find feldspar and quartz both, but we cannot find feldspatite and quartz. Okay, I am going to present there. Similarly, olivine plus quartz, what they will give? Olivine plus quartz, they will give you pyroxene. So pyroxene is saturated, quartz is oversaturated, olivine is undersaturated. Olivine can coexist with pyroxene, for example basalts, high temperature basalts, okay, or we can say peridotite. Okay, these are some of the example of rocks. So we can find olivine and pyroxene together, we can find quartz and pyroxene together, but we cannot find olivine and quartz together. Okay, so let's go to the peritectic system diagram or the phase diagram of this peritectic system. I have already told you during eutectic that phase diagram is nothing but it is the temperature composition diagram. As I have already told, in eutectic system, that is also known as congruent melting. Why that is known as congruent melting? Because the initial composition and final composition are same. You will get both initial composition and final composition same. You will get the final composition what? you have taken in the initial composition. But in peritectic system, we are naming it incongruent system or incongruent melting. Whenever we are considering for melting process, incongruent melting, or if we are considering for crystallization, then we are naming it as incongruent crystallization. Why it is incongruent? Because we have taken some initial composition and the final composition will be different. The final composition will be different. So I will describe that. I have already told this in eutectic. Now I will describe this peritectic, how this incongruent system is going to crystallize, or how the medial compound will be produced. Okay, so let's take the example of fosterite and quartz. So what is fosterite? It is magnesium silicate, right? It is magnesium silicate. It is your olivine group of minerals. Quartz means it is pure SiO2, right? So what happens? Okay, exact formula of fosterite is Mg2 SiO4. Exact formula of fosterite is Mg2 SiO4. Then okay, the diagram is like this. This is eutectic point, this is peritectic point. P stands for peritectic. Peritectic point. It is also known as reaction point. Also known as reaction point. Okay, why it is known as reaction point, I will tell you. Okay, then E is your eutectic point. Eutectic means, I have already told you in eutectic system, that is the point where there will be simultaneous crystallization of these two endpoints. There will be simultaneous crystallization of two endpoints. But in peritectic that will be different. Eutectic, the definition of eutectic is same. That means simultaneous crystallization of two endpoints or two members, simultaneous crystallization of two phases. But in this peritectic system, that is not this olivine and quartz. Okay, there will be intermediate compound, as I have told, that is pyroxene, named as enstatite. This is your enstatite or pyroxene. What is the symbol? Mg2Si2O6. This is your sorosilicate. Pyroxene is sorosilicate. We have studied silicate structure in mineralogy, right? This is your sorosilicate. This is nesosilicate. That's why I have written here. This is your what? Nesosilicate means 1:4, and sorosilicate. Sorry, not sorosilicate. Chain silicate. Pyroxene is chain silicate, single chain silicate. So 1:3. Okay, Si2O6 means 1:3. So as you can see, SiO4 plus SiO2, that becomes Si2O6, right? SiO4, Mg2SiO4 plus SiO2, that will become Mg2Si2O6. Okay, so this point represent enstatite, this line represent enstatite line, right? Here I have marked it dotted. Why I have marked it dotted, I will say you. This field is your fosterite plus liquid, this total field, right? This field is fosterite plus liquid, this field. This total field is fosterite plus liquid. Then this field is enstatite plus liquid. This field is your quartz plus liquid. How I am marking marking these fields? I have already told you in eutectic, right? Fosterite plus enstatite, this is your enstatite plus quartz. And as I have told you, these are the liquidus. These are the liquidus. Liquidus means above that it is all phases are liquid. In x-axis what we are taking? We are taking composition. In x-axis we are taking composition. In y-axis what we are taking? Temperature. Right? Here this is temperature of fosterite. Here this is temperature of quartz. Obviously temperature of quartz will be lesser than temperature of fosterite. In my diagram it may appear same, but it is not same. It will be somewhat like this, right? Temperature of quartz should be lower. Okay, so what happens here? See what this okay, I will say let's take a composition somewhat here. As I have told you, this is fosterite, means this is 100% fosterite, and fosterite will decrease in this direction. So this is the direction of increase in fosterite, and this will be the direction of increasing quartz percentage. Right, quartz will be 100 here. Okay, told you in starting of eutectic system how this is increasing. Here fosterite will be 0, 0. Here fosterite will be 100. Here quartz will be 0. Here quartz will be 100. And as I have told you, TFO means it is the temperature at which, if I am taking 100% fosterite or pure fosterite, so it will start crystallize at this temperature. If I am taking pure quartz or 100% quartz, then it will start crystallize from TQZ or T quartz or temperature quartz. So this point X, I am representing a composition here. That means it is having composition of this, it is having composition of this. Let's say fosterite 90 and quartz 10. Let's say fosterite 90 and quartz 10. Let's say I am taking this percentage, means fosterite 90 and quartz 10. It is having a temperature of somewhat here, which is greater than TFO, which is greater than the temperature of crystallization of pure fosterite, or temperature of crystallization of, at this point the temperature of crystallization will decrease, right? I have told you, if that is 100% fosterite or pure fosterite, the temperature will be this. If that is pure quartz or 100% quartz, the temperature will be this. When we are adding quartz to the fosterite, when we are taking the combination of fosterite and quartz, when we are taking the mixed composition of fosterite and quartz, then what will happen? The temperature of crystallization will decrease. The temperature of crystallization will decrease. This is the graph. These lines are representing the graph of temperature of crystallization and composition, right? For a composition, let's say this is the composition, this is the composition, and this is the temperature of crystallization. I am marking it in this so that you can understand. This is the composition, this is the temperature. Okay, for this composition it will crystallize at this temperature, not at TFO, right? It will crystallize at this temperature. If I am taking here a composition, it will crystallize at this temperature. If I am taking a composition here, it will crystallize at this temperature. Okay, whenever I am adding some amount of quartz to fosterite, if I am changing the composition, the temperature of crystallization will decrease. The temperature of crystallization will decrease. Okay, so as I have told, let's say this is the initial composition, X is the initial composition, then what will happen? So this is the initial composition, then it will cool down, the temperature will fall until it will touch the liquidus. Until it will touch the liquidus, what will happen at x? How many phases are there? At x, what is your phase rule? P plus F is equal to C plus 1. I have told you P plus F is equal to C plus 2 when there is two variable, there are two variable, temperature and pressure. But in magmatic system or igneous system, we are taking one variable, that is only temperature, because we are considering the magma is fixed at its chamber, right, and it is getting cooled. So the temperature is variable, pressure is constant. That's why I put here 1. So degree of freedom will be equal to C plus 1 minus P. C plus 1 minus P. At x, what happens? There will be only one phase. There will be only one phase, that is the liquid. Because in liquid, fosterite and quartz both are there, but you cannot separate them, so number of phases is 1. So what will be the degree of freedom? Yes, we are taking peritectic, means it is binary peritectic again. This is binary system. We have taken two end members, fosterite and quartz. Okay, enstatite is the middle compound, but we cannot say enstatite is a different component. How many components are there? Magnesium and silica. Magnesium and silica. So there are two components, magnesium and silica. So component are 2. Degree of freedom becomes 2 here. Okay, degree of freedom becomes 2 here. 2 plus 1 minus 1 will be equal to 2. Right? Number of component is 2 plus 1 minus phase is 1. So degree of freedom becomes 2. But as it is in liquid form, we are not going to calculate this degree of freedom. This is only, there will be only decrease in temperature. Composition will not change. Composition will not change until there will be crystallization. Okay? After crystallization starts, then only composition can migrate towards quartz. After crystallization start, what will be the first crystal to crystallize? At this point, which one will be first crystallizing? Your fosterite. At this temperature, for this composition, when it touches this point of the liquidus, that means when it touches this temperature, fosterite will form fast. That's why I have written here fosterite plus liquid. This field is of fosterite. That means at this point, the first mineral to crystallize is fosterite. When the fosterite is crystallizing from the magma, it is crystallizing from magma. That means magnesium is removed from the magma, or it is decreased from the magma, and the percentage of quartz will gradually increase. The percentage of pure CO2 will gradually increase. So it will move in this direction. Along with cooling of temperature, the composition will shift towards quartz. That I have told in eutectic system while making you understand eutectic system or binary phase diagram, right? Fundamentals of binary phase diagram. Then I was telling about that. Okay, so similarly here in this case, when this is the initial composition, when it touches this temperature at this point, let's say this is P1, we have taken here, let's say 1 point. Okay, at point 1 what happens? At point 1 there will be phases will be equal to 2. What are the phases? One is fosterite solid and another one is liquid. There are two phases, fosterite solid and another one is liquid. Number of component is 2 always, as I have told, binary. Okay, so degree of freedom will become 1. 2 plus 1 minus 2. Component is 2 plus 1, number of phases are 2 at point 1. Okay, 2 plus 1 minus 2 will become 1. So what will happen? It will start to move in this direction. As I have told, the composition will be shifted towards quartz, temperature will be decreased. So it is moving towards quartz. Okay. Then from 1 to P, same process will happen. From from 1 to P, what will happen? Same process, fosterite plus liquid. Fosterite start crystallizing, or fosterite is removing from the liquid. Okay, fosterite is removed in form of crystal from the liquid. Okay, then what happens at point P? So here I am representing temperature. Okay. So what happens at point P? What happens? So 1 to P, similar process. Number of phases will be 2, fosterite plus liquid. Degree of freedom will become 1. When it reaches point P, or peritectic point, what happens? As I have told, P is also known as reaction point. It is also known as reaction point. Okay. At peritectic, you can see that is the point which is lying in between two liquidus. This is the liquidus of fosterite and this is the liquidus of enstatite, because I have written here enstatite plus liquid, right? So what happens at point P? This is fosterite and this is enstatite. Also this is known as temporary eutectic. It is also known as temporary eutectic. Why it is known as temporary eutectic? Let's see. So when it touches P, when the magma touches P, what happens here? Number of phases will be, what happens at P? Fosterite is crystallizing, as well as there will be formation of enstatite. There will be a formation of enstatite. As I have told, this is the combination of this fosterite. This is the common point between this is fosterite liquidus and this is enstatite liquidus. So this is the common point between fosterite field and enstatite field. So at P, what happens? Fosterite will form and enstatite will form, and there will be one liquid. There will be liquid also. So what happens? Phase becomes 3. So degree of freedom becomes 0. How? When phase becomes 3, then C is 2, component is 2, 2 plus 1 is 3 minus 3 is equal to 0. Okay, number of component is 2 plus 1, that will be 3, minus number of phases will be 3. So degree of freedom becomes 0. So when degree of freedom becomes 0, we are naming it invariant. What we are naming? Invariant. That means the magma will not move from this point. That means at that temperature there will be simultaneous crystallization of fosterite and enstatite. Okay, and there is an liquid. So what happens? The magma will not move because degree of freedom becomes 0. Okay, so due to this what happens? It is known as temporary eutectic. So as I have told, eutectic means simultaneous crystallization. So here simultaneous crystallization between fosterite and enstatite. Here fosterite and enstatite, they will be simultaneously crystallized. That's why it is known as eutectic. Then again, why it is temporary? Because then we will come to this part. P is also known as reaction point. P is also known as reaction point. Okay, why it is known as reaction point? What happens at P? Fosterite will react with quartz to give enstatite. Fosterite will react with quartz. What happens at P? Fosterite will react with quartz to form enstatite. Okay? At P, what happens? The early formed fosterite will react with quartz means SiO2. Quartz means SiO2, that is in liquid format, that is in liquid form. Okay, maybe you are having doubt that how quartz is not crystallized yet, how it is reacting with fosterite. That is not quartz, that is silica, that is silica, or and that is in melt phase, that is in melt phase. So fosterite react with melt to produce enstatite. Fosterite react with melt to produce enstatite at point P. So as there is reaction, it is known as reaction point. It is known as reaction point. Okay. So what happens